So I'm going to introduce our next speaker, Lindsay with Milan, rocket scientist, physicist, and astronaut. He worked for Milan for 28 years. He provides support to all our segments in the industry. The assistance he provides is inside technology, application design, installation, maintenance, inspections, troubleshooting, and training. And previously, Ron worked as a geologist in the soil and groundwater remediation industry. So if we can give him a round of applause, everyone.
Astronaut?
Astronaut, if they were listening.
Great. So, morning everybody. Well, it looks like it must have been a late night, kind of thin crowd this morning a little bit compared to yesterday. So happy Valentine's Day for the couples that are out there. And please, somebody remind me before I go home that I got to pick up some flowers or something for my wife when I go home, because I've been gone for almost 2 weeks straight. So that'll, even though she doesn't believe in Hallmark holiday, it wins me over. So anyways, so we're going to be talking about troubleshooting septic systems, operation and maintenance and troubleshooting systems. So everybody in here, obviously over the past couple days is more aware of what's going on with the state code initiative. And so, you know, who knows how and if anything's going to go with that. But if it does go forward, obviously there's going to be a tremendous amount of work for everybody in here. And and there will be evaluations, how they're going to be conducted, who knows? You know, chances are it may be kind of like at time of sale programs now, where you go out there and you report your observations, and a second party is going to make that pass-fail decision. But at some point, there's going to be a lot of issues that are going to be discovered out there. And so it's a business opportunity for you to broaden your horizon a little bit in your services and get involved in troubleshooting, operation and maintenance of systems, and so forth. And even if the code doesn't go through, there is a tremendous shortage across Michigan for personnel to do service work, such as troubleshooting, evaluations, and operation and maintenance of systems, including advanced treatment systems. Severe shortage out there, so there's a huge business opportunity for you. You know, those of you that are pumpers, oftentimes you got into the excavating business. Some of you installers got involved into pumping business. Why? Because those two businesses are compatible with each other, right? And so you can broaden your business service range. The same thing with servicing systems. It's another opportunity to broaden your service and so forth. And I think the reason for the shortage we have out there is because it takes more of a learning curve, a longer learning curve, to try to figure out how systems all work and all the dynamics that are involved in the operation of a system and what's involved in problem, malfunction systems, and so forth. And where do you get that training opportunity now? You know, those of you that have been around long enough in the industry, and perhaps you attended the Michigan On-Site Wastewater Education Training Center that was in Oakland County. And that was a tremendous resource for getting knowledge on on-site systems. Those of you that attended, you realize that there was classes on design, there was classes on conducting operation and maintenance, how to do at time of sale evaluations. And the great thing about that class, it was hands-on. And probably a lot of you are like me, I'm a learner by hands-on. I can't sit here and listen to PowerPoint presentations. However, right now in our environment here in Michigan, that's all we have. So attend every training opportunity you have, and you're going to walk away with a little building block. And before long, you're going to be able to build up your knowledge structure where you have a comfort level to go out there and perform service work on systems. So. And then networking is so important. It was kind of refreshing yesterday, past couple days actually, to see all the networking that's going on. And if you can find a mentor, somebody that's going to help you broaden your knowledge level, that's so beneficial. There was a contractor here, an installer yesterday, that he was mentoring a new installer into the business, and it was encouraging him to, come visit my site, welcome to learn. Even knowing that, that new contractor is going to be his competition someday. So, so try to establish some mentoring if you can. I know many of you out there, and I offer that. I try to share as much knowledge as I can with you. If you call and have a problem site, I'm more than willing to go out there and help and mentor a little bit. So we're going to talk about equipping yourself to conduct troubleshooting services. And when I say equip yourself, I'm not talking about equipping yourself with equipment, because if you're getting involved in troubleshooting and operation and maintenance, literally you could be in business for $500 worth of tools in a pickup truck. So you don't need to get a $300,000 excavator or a big pump truck or anything like that. So it's very easy to set up. So financially, the investment is very minimal. The investment in the knowledge is where you need to gain that. And so those of you that are involved in septic system malfunctions realize that's a very stressful time for that facility or that homeowner to deal with psychologically and financially. So we want to make sure that we go out there and we diagnose what that problem is, so we don't run into situations where we replace a system and then several months later, a year or a couple years later, that system fails again. And we probably all have a lot of war stories regarding situations like that. When I was putting this together, one popped into my head. It was a nursing home facility. That system failed in less than a year. So they contacted the installer and said, hey, you're replacing our system. You messed up on your install because it failed. And so they were getting ready to spend all that money to go in there, rip out this system and replace it. And somehow I got involved, and it's like, well, let's try to figure out, well, what was the cause? And so it had multiple issues. They guaranteed if they were to have just simply replaced that system, guaranteed within another year that system would have gone belly up again. And so then they'd probably chase that contractor again. Hey, you messed up again. Where it was not his fault at all. And so in another case is you don't want to spend unnecessary money for that homeowner, because financially that can be very stressful for them. Some people may not afford it. Here's a real severe horror story. Is last year a friend of mine called up. He's installing a system in a repair situation, residential, and he put in the system, and it was an $85,000 installation. Yeah, $85,000 for residential. Can you imagine being a homeowner and forking up $85,000? But once we get into a lot of repair situations and we got to start applying advanced treatment systems, that cost just grows right up. So it's not uncommon now to see $40,000, $50,000, $60,000, $70,000, $80,000, $100,000 residential systems going in. And so anyways, a friend of mine, he called up and he is irate. He goes, I feel like a criminal. He goes, I had to start, and by the time I finished my installation, I encroached onto the existing field there. He goes, I dug into it, there's nothing wrong with the field. It was dry, no biomat evidence and so forth. So he kind of probed a little bit more, found out all it was simply a crushed pipe between that tank and that drain field. Could have been a $2,000 repair. He says, I cannot tell this homeowner. He goes, I just feel like a criminal. So we don't want to fall into that situation. Can you imagine being on the other end of that homeowner, and you find something out like that? Lawsuits are going to be flying. So we got to apply diagnostic skills. And so our job is no different than that of a doctor. A doctor's job is pretty much routine until all of a sudden they find an issue, and then they have to, do all kinds of checks and so forth, maybe some lab work, and try to figure out what the problem is before they come up with a cure for you. And, the only difference between us and a doctor is a doctor is, they're highly praised and so forth. And unfortunately, we're always kind of looked down upon in our industry, unfortunately. But we have equally important job. And then secondly, the other difference is obviously a doctor makes a whole lot more money than us. So some of the skills that are needed, you don't have to be a PhD to get into any type of service work. You just have to have some basic knowledge, some basic, high school level chemistry and math. You definitely need to know wastewater characteristics, and that's what we're going to kind of go through today. And our design practices, you got to be familiar with design practices, construction practices. So if you're going out to a system, what's this particular designer usually do? How would this system be constructed? So you need to know those details. And again, all our systems are soil-based. So no matter what we do in this industry, an installer or a service provider, we need to have some basic soil knowledge. So you really should take a class on soil science just to understand the processes that go on in soils. And again, practical knowledge of pumps and electricity is very important. Every year, the number of pump systems keep climbing. And if we get into a state code situation, which is going to have construction code practices, I will guarantee you we're going to have a very large increase in raised systems, which will all require pumps and controls. So we need to have a good understanding of their function and how to troubleshoot them. So there's all kinds of reasons why a system may malfunction. Many of them you're familiar with. We could have a tank failure, component on that tank fail, hydraulic overload, organic overload, too much food going into the bugs creating problems, problem design, problem installation, and system poisoning. There's all kinds of toxins that we are now putting into our systems that can inhibit the capability of the bacteria to do the proper treatment. Roots, common problem, lack of maintenance, as many of you as pumpers will probably observe. Typical homeowner, hey, haven't pumped my tank in 20 years. But usually what you're going to find, it's usually not just one of these issues. Usually it's a combination that you're going to see. So let's take a look at the two processes that we have on a conventional system. And that's the processes that go within the septic tank, and then we'll look at processes within the soil. And in the septic tank, most people just think a septic tank is what? A vessel where poo stores until we pump it out, right? It's not. It's actually a very complex vessel. So kind of think of it as a physical, chemical, biological reactor. We have all kinds of reactions going on in that tank. You have different sets of bacteria. You got methane-forming bacteria. You got acid-forming bacteria. One happens to one set that can affect the other set. So there's a whole lot of activity going on in there. Again, as everybody is probably aware, septic tank is anaerobic. So those bugs thrive without free oxygen. They get their oxygen. They strip it off of other compounds in that waste stream. But those bugs are real slow. So very slow multipliers. So it's kind of interesting, you get involved in operation and maintenance and you have an opportunity to look at that tank every single year. On a startup, first couple of years, you're going to see a rapid buildup of that sludge layer. Perhaps, say 6-8 inches of sludge. That first couple of years, and you're thinking, wow, we're going to have to pump this tank in another year. And then after a couple of years, we get a sufficient population of bugs in there, and they start degrading that sludge blanket in the bottom. And you actually start seeing it kind of reaches a steady state. And that growth rate now, accumulation rate is much slower. And so we can have a tendency to pump tanks a little too often in some situations because it takes much longer for those microorganisms in that tank to establish a sufficient population. And if you look at the treatment in a septic tank, you have to realize that 50 to 80% of our treatment, depending on what component we're looking at in wastewater, occurs in that septic tank, not in the soil. So that septic tank is so critical that we maintain a proper environment in there. So we got to maintain the stratification, the scum layer, the sludge layer, then in between, we got to make sure we got a good clear zone in there. And we'll talk more about tanks here in a little bit. So in order for that to function, that has to be a very quiet zone. We can't have a lot of turbulence going into that tank, and we can't have any toxins and so forth that's going to inhibit the bacterial growth in that tank. So let's take a quick look, 100-mile-an-hour view of what happens in the soil. Let's kind of blow up the soil right underneath our gravel layer in a bed system. So soon after startup, you're going to get biofilms. I don't know if you can, yeah. Anyways, you're going to see biofilms developing, microscopic level of biological film growing around each soil particle. And housed in that biofilm is our bacteria that are doing our waste degradation. So as that wastewater comes down over that soil particle, has contact with that biofilm, the organics in that waste stream get absorbed into that biofilm, and the bacteria in there digest it at its leisure. What's critical for this is an aerobic process. So we need to make sure that in that drain field, we get proper aeration occurring. And so we need to have air coming through there. As the air passes through, that gets absorbed into the biofilms, and the aerobic microbes can thrive in that particular case. Also does a great job of reducing pathogens. As the pathogens come out of that septic tank, they actually come from our gut, which is anaerobic, come from the septic tank that's anaerobic. And they have a hard time thriving in an oxygen zone. So right away, as soon as they hit that soil, they may get physically filtered. Some are going to die simply in the air contact, and some are going to get absorbed into that biofilm and be prey for the bacteria, the aerobic bacteria that are more aggressive. So bacteria, they need a foundation, which is our soil particles. They need contact time. So that's kind of a critical component too that we'll talk about in a second. They need contact time so that those organics can make contact with those biofilms and get absorbed in there to get digested. And they obviously need a lot of oxygen. So in this illustration up here on your right is what we want to try to achieve. You want to try to keep those pore spaces open for oxygen transfer to go through. And so the soil or the water has to go through that soil in an unsaturated mode. In an unsaturated mode, that water goes through at a much slower rate. And so you have more contact time with the microbes so they can absorb the organics in that waste stream and the pathogens. Secondly, to keep the pores open, we'll get a lot of oxygen transfer there. So that helps guarantee that we're going to get that treatment. So water in an unsaturated mode through the soil goes through much slower. We have contact time. On the left there shows a saturated environment. Water in the saturated form goes through the soil much quicker. So we reduce our contact time with the bacteria. Secondly, we reduce our capability of getting oxygen transfer. And before long, we're going to start having problems with the system. So in a gravity distribution, you have your gravel bed or trench. You got that 4-inch perforated pipe that goes through there. So we get uniform distribution over the entire field. So, you know, that 4-inch pipe, all that effluent dumps out of all those holes throughout the field, right? Wrong. Gravity distribution, we can't get uniform distribution. So what happens in a gravity type system? It's usually going to dump out at certain points within that pipe. You're not going to get that entire pipe dumping out effluent uniformly over that soil body. So oftentimes it'll be at the header end. If you got a pump system, you could kind of create a little tidal wave through that pipe network, and you could see it at the footer end. So we really don't have any control. But what happens, it kind of comes down through there in one spot. We hydraulically overload that. Then over time, we start getting a biomat developing. And when people hear biomat, they panic. We got a failure going on. Biomat is actually desirable. So what a biomat does, kind of think of it as, so it creates a membrane on there. It's bacterial growth. It can be comprised of lint, inorganics, and so forth, some fines and so forth. But it starts getting anaerobic. Underneath there, you got aerobic bacteria kind of keeping it in balance. So it kind of creates basically kind of like a valving mechanism. And so it slows down. So it started up, kind of lost it there. So it started up as it goes through real quick. Till we establish that biofilm, we're not getting full treatment coming out of that system. So once that biomat is established, It's kind of like slowing it down. So it'd be equivalent, kind of like taking a garden hose and putting it in one spot. Then over time, we throttle down that garden hose where it's just dripping. So dripping through the soil in an unsaturated form. So that's in a gravity type system, we require that biomat to create that unsaturated condition where we can get full treatment. In low pressure distribution system, we engineer that uniformity across there. So typically in a low pressure distribution system, we're not relying so much on that biomat formation because we're spreading out the organics and the wastewater through the entire infiltration area of that bed system or trench system. So, but if any of those processes are compromised, whether in the drain field or in the septic tank, we get, our textbook failure there, where everything gets all black and slimy. Slime is basically anaerobic bacteria that are creating slime protective layers and so forth, kind of creates a goo and really chokes off things. It gets real severe, then come to the surface, and then we have by regulatory definition of failure. So bacteria, they need a certain condition to thrive and be healthy. So if we're getting into maintenance programs, need to have an understanding of wastewater characteristics, and if we're starting to have some problems, what are some of the analytical things that we can look at to help us make a determination of problems? Now, our best tools oftentimes are our eyes and our smell. So temperature. Bugs require a certain temperature. Ideally, bacteria like 77 to about 95 degrees. That's their ideal growth rate temperature. Coming out of a septic tank, that temperature is about 50 to 70 degrees. So a little bit lower, so it kind of slows them down a little bit. Now, bacteria, after about 40 degrees, 39 degrees, they become dormant. And we've pretty much lost our treatment at that point. So drastic temperature fluctuations can harm the bacteria, could kill some bacteria, but kind of makes them a little bit sluggish and we can lose treatment. High temperature is more of an issue in a restaurant type setting. Anything that has food establishment, we really need to be concerned with temperature. So, sources of high temperature could be somebody, releasing a jacuzzi tub through the system, doing excess hot water laundering, hot water cleaning in a restaurant, which we desire, versus over chemical sanitation. But we have to make sure our grease tanks are adequately sized to capture that grease. So what will happen is grease that solidify like butters and lards and Crisco and that type of stuff, after about room temperature, it starts flowing. So we want that to solidify. So on those two samples there, on the bottom there, on the right is a restaurant coming out of the same tank, same restaurant. On the right happens to be during a low flow period, say, a Tuesday on a restaurant. It actually looks pretty good. On the left there is a peak period in that restaurant. And, say a Friday night, they're doing a lot of dishwashing, that water is hot at that point, and you're gonna have a tendency to carry fat, oil, and greases. So you gotta understand the flow characteristics in a facility if you're gonna evaluate problems, because if you look at the right, you might think, okay, we have no problem, we don't have any fat, oil, and greases getting through. So we gotta be concerned with that. Bugs also need a certain pH range. Going back to your high school chemistry, if you remember the pH scale, the lower the number, the more acidic it is. The higher the number, the more basic or alkaline that is. So water is neutral, it's 7. A lot of people think that septic tank effluent is acidic, and it's not. Typically what you're going to see, it's 7, it's neutral. Bugs in the septic tank thrive at about 6.5 to 7.5, somewhere in that range. If we start getting outside that range, the bugs get real sluggish and they're just not doing their job like they should. So pH is an indicator that we can use for determining if a problem is occurring. Use pH strips or like in a pool type setting, or you can get a pH meter and so forth. So again, looking at some of the acidity of systems, milk is about 6.5, so that's kind of acidic. On the acidic level, any kind of dairy products. Coffee is about 5. So those of you that drank a Coke or a Pepsi this morning, what do you think that pH is on that. It's actually pretty low. It's 2. It's pretty equivalent to lemon juice. So another trivia thing is the enamel on your teeth. At what point do you start dissolving enamel on your teeth? 5.5. So watch out people that drink Pepsi all the time. So we got to be concerned with the pH. So sources of high pH could be somebody that's dumping a lot of coffee down the drain, doing a lot of excess baking and so forth, practices, pop getting down the system, and cleaners. So a lot of the convenience stores, they're under contract to provide fresh coffee, and they're supposed to dump their coffee every, X period of time. So you get a lot of coffee input, like in convenience stores, restaurants, and so forth, and that can affect that. High pH, typically it's a result of cleaners and so forth, more alkaline type cleaners. So dissolved oxygen concentration, another real quick test that you can do out in the field with a little colorimetric, or you can get a DO meter. Septic tank effluent has a DO of less than 0.5. It should be anaerobic, so lacking dissolved oxygen. If we suspect there's a problem in there, a lack of scum layer, that water looks pretty clear and so forth, bet you if you do a DO test, you can show that you might have groundwater infiltrating in that, because your DO is going to be higher than the typical 0.5. Coming out of the advanced treatment system, DO testing is very critical. We always expect those advanced treatment systems to produce more than about 2 milligrams per liter of dissolved oxygen. So once we get, so those are some of the characteristics that bugs need to thrive in. So if we're starting to run into a problem, there are some analytical results that we can do that you really need to be familiar with, and especially this one right here, because you're going to hear it all the time. And that's the biochemical oxygen demand, or BOD5. Probably have heard the BOD5 mentioned somewhere along your career path. And what it is, it's a laboratory method that measures the amount of oxygen that it takes for those bacteria in that sample to degrade that waste. And so it's kind of a measurement of the waste strength. Another way of kind of thinking about it is to simplify it, think of it as food for the bacteria. So if you got more BOD, you got more food for the bacteria. Bacteria thrive on that, and they grow, multiply, and we can run into problems. So BOD, the domestic value coming out of residential septic tanks, typically about 140, 150. High strength would be considered something after 200 milligrams per liter. So, for example, high strength in a C-store. I mentioned, oftentimes you'll dump coffee. Somebody goes to 7-Eleven, gets that big gulp, and they don't like that one, so they dump it. Goes down the drain. It's a lot of sugars and so forth. It adds a tremendous amount of BOD to the system. So a convenience store, some people think, well, they just got a bathroom in there, and so waste strength isn't an issue. Well, it's quite the opposite. They're dumping a lot of stuff down the drain. C-stores are basically kind of like mini restaurants now. And so a typical C-store, you may see a BOD reading anywhere from 400 to 1,000 milligrams per liter versus our residential at 150. So that can create tremendous impact on our system. Restaurants, like a McDonald's restaurant, that BOD is typically around 1,200 or so quite a bit more. So another laboratory test you need to be familiar with is total suspended solids. It's basically just the measure of solids that are kind of free floating in that clear zone of that wastewater, that septic tank. So typical value is about 75. If we put in effluent filters, we can actually reduce that to about 40 milligrams per liter, so that's pretty typical. Sources of that would be like perhaps toilet paper, inorganics like lint from laundry, dirt, and so forth. So same causes would be for high BOD. Fat, oil, and grease is the third analytical test that you should be alert of, especially if you deal with anything with food processing, restaurants, convenience stores, and so forth. It accumulates in the scum layer, so you're going to get big rapid scum layer buildup, and comprised of animal fats, butters, vegetable oils, body lotions, bath oils, petroleum products. Petroleum products can be detrimental to the bacteria, very toxic to them. But fat oil and grease concentration above 25 milligrams per liter, you're going to start clogging your soil pores. Start clogging those soil pores, we can't get that oxygen transfer to occur, and we're going to start choking off the system. You're going to increase that biomass to the point where we're surfacing. Raises that BOD level, and fat oil and greases over time starts degrading and actually starts getting more acidic. So it's going to affect our pH and the ability of those bugs to do their treatment capability. So, kind of backwards there. Sample on the bottom is actually a distribution box in a drain field at a restaurant. You can see it's just kind of, globs of fat there. Up on the top there is actually a fat oil and grease sample from a restaurant that they're using heavy emulsifiers. So emulsifiers basically kind of turn that into liquid and it just flows. And you see in there it looks like milk or white paint. And what's kind of interesting on this sample here, the lab couldn't pick up fat oil and greases because the emulsifiers were camouflaging that fat oil and grease thinking it's water. So it's kind of interesting. So again, just to recap, BODs coming out of a residential is 150, TSS is 40, grease and oils typically about 20. Like I said, you get around that 25 to 30, you're going to start clogging soil pores. So flow volume is the next characteristic that we have to deal with, and that's what a lot of people are familiar with. You run into a failed system. Our automatic response out there is, okay, Mr. and Mrs. Homeowner, you're using too much water. Well, are we? Oftentimes it's not the case, but that's the first conclusion we always come to. So residential system, everybody's familiar with their county codes, and that's based on that BOD number of 140, 150. And so a 3-bedroom home, typically in most areas, a 450 gallon a day design flow. So our real flow, though, would be typically you're pretty accurate, like textbook, which is about 50 gallons a day per person on a weekly average. Comes out pretty close, usually. So the difference between the two is a safety factor in there. And what you have to realize, if we start operating at that design number at 450 on a consistent basis, we're going to have problems with that field. In fact, if you're operating continuously at about 70% of that design for that field, we're going to start running into potential problems with the tank or the field. Something is going to happen. And so it's kind of like running your truck full throttle. Eventually it's going to give. So same thing here. So how do we measure flow? Well, we can put a flow meter on their water service, or if we're lucky enough, we have a pump and control system that has an hour meter and a counter. That is the best way, because what can happen is if you put a flow meter on there trying to track their flow use, may indicate they're flowing 200 gallons out of that house. But what if you have a leaking septic tank? And those pumps show that you're flowing 1,000 gallons a day out of that system. Big difference between the two. So the pump method is actually the best. So anytime you put a pump system in there, I'd always encourage you to use a control panel with an hour meter and counter. So valuable when you're troubleshooting. So examples of excess flow, I think it's pretty much common sense what that is. But think of a toilet. A running toilet is notorious for causing problems. A leaking toilet can put out anywhere from 1,000 to 2,000 gallons a day through a system. And then the opposite, just this past summer I was at a site, knew the homeowners weren't there, but there was a drip, 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 just a continuous drip coming out of the inlet into that tank. So I measured it. Came out to 1 cup per minute of drip flow, and which doesn't sound like a lot, but then when you do the math, after a 24-hour period, that's an extra 90 gallons a day going through that system. So that could put that over the edge. So flow and waste strength have a direct relationship on that clogging mat formation. So we know in the middle there where it says actual 200 gallons a day for a 3-bedroom home, family of 4, BOD of 4, comes out to, we can calculate the pounds of organics that we're relying on that drain field to treat. And so So on that 200 gallons, 140 BOD, it comes out to 0.23 pounds of organics that drain field has to treat every single day. So to kind of give you an illustration of if we're operating at that design number continuously, say we're designed for 450, BOD may be a little bit more elevated, we've got almost a pound of organics. So that's a drastic difference between 0.2 and 1 pound. So then we have a situation where we have infiltration. Say our risers are leaking or our tank's taking on groundwater. Common thought is, well, so what? It dilutes it. And it's going in a drain field anyways, or effluent after the tank. Well, in that particular case, if we're leaking out of the tank, we don't have as much oxygen down deep and so forth. But if you take a look at the numbers, yes, true, we do dilute it. But we have so much more unit volume of water going out that in fact, for example, say that bottom where it says infiltration, 1,900 gallons a day, it dilutes it down to 70 milligrams per liter of BOD coming out of that system. That's over a pound of organics that field now has to treat, plus it has all that water that it has to deal with. So in that particular case, we're going to have a biomat that's going to really expand and have problems. So toxins that can impact the system. Excess cleaning products typically will impact the pH, affect the bacteria activity. Degreasers and organic, like pine sol oil, very harsh on bacteria. Paint thinners, you don't want to, talk your clients out of, do not put any paint residual or thinners down that tank. That can have a long-term effect on the system. Bacterial infection. Dishwashing detergent, oftentimes will have degreasers in there. That's why your dishes are nice and clean. So you don't want to overuse those types of products. You're going to carry grease and so forth to the field. And the same thing in restaurants, you want to try to talk them into hot water rinsing versus chemical, because the chemical oftentimes is going to emulsify and carry everything out of the field. Various metals. Involved in a site up in Cadillac area many years ago, and made a determination that they were floor stripping. There's a grocery store, and they're stripping the floor every single night and dumping it down the slop tank. Well, floor strippers have a lot of zinc in it, and it's very harsh on bacteria and kills it. And so we were able to determine that was one of the main reasons why that system failed. Medical, and what it has, it'll be toxic to bacteria and emulsifies the solids that are in the septic tank, so it carries solids out, and you're going to have those accumulate in the field and create problems. Medical issues, antibiotics, chemos, and drugs and so forth will have the same effect as, for instance, what zinc would do. So sanitizers like the toilet bowl cleaners, spray-on shower cleaners and so forth. You want to try to avoid those. Everything in the world now is antibiotic, soap and so forth. Studies have proven that regular hand soap is just as effective as any antibacterial soap that you use. So you want to try to avoid those. Now the one big thing that's really kind of evolving, and the knowledge is getting more widespread, is a compound called quaternary ammonia salts, also known as quats in the industry. And quats originally were used in hospitals for disinfection, for surgeries and so forth. It's a very harsh biocide, and it has a long-term kill effect. So for example, if you dump a gallon of bleach down your septic tank, it's going to kill it, but it will recover in about a week time. If you get an cumulative effect of quats in your system, it's got a long-term kill effect and create problems. It's very harsh in the anaerobic, meaning in the septic tank. Once we get out into the field, more in an aerobic environment, it has a better tendency to start breaking down. But you won't see quats on a label of anything. One of the well-known household items that have quats in it is liquid fabric softeners. So avoid liquid fabric softeners. Now it's kind of interesting because I looked at the shampoo that we all used this morning in our showers. And if you look on that shampoo bottle that was provided at the hotel here, it's got quats in it. So showing up in a lot of household products now. The fact that you're not going to see it known as quats if you look at a label, But towards the bottom there, if it's some long chemical name like alkyl-dibenzyl, benzyl, whatever that's pronounced as, ammonium, or that middle one, which is B-tribonium chloride. That's what's in your shampoo. You look it up, it's a quat. It's actually used as an anti-static for our hair. So typically you're going to see kind of like followed by ammonium or by chloride, and you know you got quats in that. And you want to try to avoid those because they have a long-term residual effect. It's going to start balking up the solids in your tank and emulsifies and send the solids out to the field. So once we know our general characteristics and some of the analytical tools that we can use to evaluate a system, we got to go out to a site and make a diagnosis. So you want to, first of all, obviously we're, all defenders of public health. We want to make sure that that system is not going to be a immediate detriment to public health. Then we want to use a questionnaire. You want to try to get a hold of anybody that was involved in that project and start interviewing them, see if you can find out any problems. So when I'm driving up on a site, right away my radar is going off. As I'm driving up there, I'm kind of looking around, okay, what's the site topography? There's a new barn over here. Could that have an input? Look at the, was there a new gas service or irrigation through that system that could have cut through part of the field? Look at the number of cars, so just visual evidence. Then once you're on the site, kind of walk over and you look for obvious problems that are occurring or that could hamper the system. Bottom right, a system located at the bottom of your walkout basement. That's kind of a terrible area for a system because oftentimes you get a lot of water accumulation and so forth there. So you want to look for drainage issues. Now sometimes on systems they can be very easy to determine the cause of problems. Others are a little bit more challenging, especially if it's got seasonal effects like this particular one here. The red indicates some trenches that for several months out of the year they're underwater. You go out and look at that site in July, you'd never know that, there was water standing there and you're kind of scratching your head what's going on. So once we get into the septic tank, we're all familiar with what a septic tank smells like. So it should smell like a septic tank. So if we get any kind of an off odor, we get any kind of a chemical odor, or no odor, that's kind of cluing us in that something's going on in this system. We need to evaluate a little bit more. And you should have those three distinct zones, the stratification in that tank. And so we should always measure the sludge and scum in there. Oftentimes, if you're in there with a pumper hose, you're just kind of mixing things up. You really can't get a good view of what's going on. So you really should use a sludge judge measuring device and see what's going on in that tank. So lack of stratification could indicate, perhaps, especially with older softeners that are regenerating every 2 days, that can impact the system. Get a lot of hydraulic overload. You can get some sodium chloride going in there that could impede the system. Mixing tank contents. So if they have a basement injector coming in that tank, we have a tendency sometimes to mix things up. Or a situation where the tanks are located remote from the house and they got a little grinder basin. They have a grinder pump in there and they're pumping up. So we're creating a lot of turbulence in that tank. Secondly, with a grinder, we're macerating the solids. And so you got minute particles now that take a tremendous amount more time to settle out. And so kind of look at, what's going on in that tank. If you got a situation where that septic tank has an effluent filter that's prematurely clogging, that filter should withstand the duration of your pump out intervals. If it's prematurely clogging, something's going on. Typically, it's a hydraulic overload situation, or it could be organic overload, overuse of that system, a poison tank, or oftentimes just simply an undersized filter, especially in a 1,000-gallon or a single compartment tank. So just realize that a septic treatment won't talk. I'm not going to elaborate any more on the septic tank function and so forth, but if it's leaking, it's not going to be working. And you can oftentimes, in the, perhaps the dry time of the year, you're not seeing any evidence of infiltration, say in this particular example, a riser, but you can see evidence of it. So look for, telltale signs where, am I getting some infiltration? For instance, if you see a lot of sand and soil sediment kind of running across into that tank. I think your last speaker today is going to be talking about this, so I'm not even going to touch about this, but common problem. So if you got a real thick sludge blanket, you want to use, you can use your shovel sometimes to gauge the depth of that scum. It's kind of like an iceberg. It's actually kind of a little bit deeper in there. So you get a real thick sludge blanket, actually a little L-shaped rod, stick it in or turn it, and you can get a good measure of that depth of that scum layer. Sludge judge. What's real nice about the sludge judge or something clear like that, you can see the entire profile of that tank. In the bottom there, you can see the sludge on the bottom. You can tell the color of that sludge, which is a telltale sign of problems. Then you can see above that, it's clear. You want to see that clear zone. So if we got a poison septic tank, you may see, if you're looking at a tank often enough, you may start seeing a thinning of that scum layer. You may start seeing a thinning of that sludge layer. That's kind of telling you things are emulsifying, bulking up, and moving downstream. So oftentimes you'll start seeing a lack of a clear zone. Clear zone will start getting darker and so forth. The sample on the right here actually was from one of the members that's sitting in here this morning, I believe. Many years ago, we went out there and took a look at it. System failed in about 6 months. He was told by the owner, "You're coming back to fix it." Happened to be on a drugstore. And so he and I went out there and evaluated it, and we did some sampling. And on the right there, you can see that it's all dark. So that's kind of an indication that tank is bulking. Basically, you get gases and so forth building that sludge layer, just churning things up. You're not getting any settling and so forth. And so we did analytical on there. And that was smart on his part because he was able to take that analytical result back to the management. It was on the drugstore. And it found out that they found an employee who was dumping photo developing fluid down the tank. So, you know, he could have been, if he didn't do any analytical work and checking on that, you know, he would have been out money replacing that field. And then they would have had a failed system again within several months. So lab verification is so important. Soil drain fields, not only, like we just discussed, that there's a lot of treatment going on in there, but that drain field is also a conduit, or the soils around that drain field are a conduit to get that water, once treated, away from the site. So we got to be concerned with that, which brings up the compaction issues and so forth. So compaction is a little bit harder to identify, because typically in a compaction situation, oftentimes you're going to get not a long life, but a relatively long life. You know, you may see 5 years of life out of that system before it starts showing significant problems and so forth. So you kind of got to go back to, okay, well, you know, the system's in front of the house, and you know the drain field's right there. You know for a fact that they had to have had a lot of construction traffic on there when they're building that house, and like, okay, kind of suspect we got a compaction issue. So once you get into dispersal field, you also want to evaluate, you know, how thick was that soil cover on there? What was that soil cover? We want that system to breathe. You don't want to put a clay cap on there. What kind of barrier was used? So clean stone, oftentimes those of you that are installers, you may have health departments harp on you that hey, your stone doesn't look clean enough. And rightfully so, they should be. Because if you've got dirty stone on there, if say you had a medium sand that you're dealing with, you put the system on there, and that system's sized for a medium sand, you get a lot of fines on there. Now you got a 1/4-inch layer of silt and fines. Well, that system should have been designed for silt and clay-sized particles. So when we get into sand fill situations, again, we want to make sure we have the right gradation of sands. If we have too much fines in that, we have the same situation as I just described. And those fines create smaller pore particles. Smaller pore particles saturate easier, and we start losing our treatment as a result of that. So just looking at a design the other day where they had 2NS sand, and then underneath it, they just indicated clean sand. So what is clean sand? And we all probably have different definitions. So they really needed to put a specification on there. So compaction from mound systems, again, oftentimes you got to kind of backtrack and figure out, okay, well, how is that system installed? So a situation like this, they stripped off the soil and drove gravel trains on top and dumped the sand fill. So that's going to create compactions. They're going to get a little bit of life out of that, but eventually it's going to have problems. So once we get into mound systems, if we have a failure at the top, you're bleeding out on that mound system towards the top, typically the same indication that you would have on an in-ground system. If we're starting to bleed out on the basal side at the toe of those slopes, usually that's an indication perhaps the system was undersized for their soils. It could be that the soils were compacted during construction. We could have, seasonal saturation, wrong soil evaluation, and site characteristics on that site. So we need to identify what could cause that. So this is a mound failure system. And I know for a fact there was all kinds of traffic running back and forth on the downslope of that mound system. And sure enough, as soon as that water gets treated, it hits it, it goes down, and it's going to blow out. Many years ago, I believe it's in Macomb County, they were having problems with mound systems blowing out. Myself and Dr. Ted Loudon not Dr. Ted Loudon, Dr. Makma from MSU, he's a soil scientist. We went out to several of those sites out there and did soil pentrometer tests. It's basically just a probe you put in there and you measure the pressure it takes to push down on that pentrometer. And so we went into areas where we knew there was no traffic and got a reading. And then we went in around the basal area of that mound system and did that, and we had a 10-fold increase in that the amount of pressure that we could apply around that mound system. And turns out, sure enough, it was common practice around there, just kind of, run your equipment all around that mound system. So frozen systems will pack that. Low pressure distribution systems. As I indicated in the very beginning, we actually engineered that to get a uniform distribution over the entire infiltration zone. However, those pipes will accumulate solids and they need to be flushed out periodically. What that is, every couple years, every 3 years. I'll tell you though, most of the systems I know that have completely clogged up are about 18 to 20 years old. And then it's shot. Typically what you're going to see is the gravel is still going to be nice and clean, but effluent can't move through that pipe network and your pump is just going to be deadheading. And then you get in the upper left corner right there, you can try flushing it out and you can just get this big blob of slime and poo, whatever, coming out of that. And so be real aggressive. You can bottle brush it in the bottom left corner right there. Do that periodically every couple years. That system's going to be, pretty functional. So one way we can determine if a low pressure distribution system is having clogging issues or not is measuring the squirt height. So oftentimes those of you that are familiar with startups on a low pressure distribution system, health department comes out or engineer and they want to see that squirt coming out of the last hole. Well, that squirt height needs to be recorded somewhere because that is so vital information to have for future monitoring. Pump does two things, makes flow, makes pressure. If it ain't making flow because the holes are clogged, you're going to see an increase in pressure and it's going to give you a clue that we need to clean out those laterals. So root intrusion, I don't think I need to elaborate any on that. Panel inspection, we kind of talked about that yesterday at the round table. It's kind of an intimidating point for many people troubleshooting and so forth, just because there's so many variations of panels, so many variations of floats and so forth, and can get kind of intimidating if it's not something you work on all the time. But realize that you got full support from typically whoever provided the pump, or you can go back direct to the pump manufacturer or to the manufacturer, and most of them have tremendous troubleshooting support that they can provide you. So, but one thing you want to do in a panel is determine, hey, are we getting moisture and corrosion getting up into that panel? Because that can wipe out a panel in as little as 6 months. So I used to open up, whenever I go to control panels, I used to open them up, and if I can smell sewage in there, it's like, okay, we got problems. We got moisture and we got gases coming up from that tank. It's going to create a problem. I don't do that anymore. I kind of stand back because the last time I did that, had a wasp nest in there. The electrician left a hole in the bottom of the panel, opened it up, had a bunch of wasps fly out, and got stung a couple times in the face. So try to avoid that now. So again, numerous float configurations, and you get into a repair situation, as we discussed yesterday at the round table. You got to kind of figure out what floats are needed, because there's just so many variations of floats and various operations and so forth. If you do anything with pumps, controls, or some of the alternative systems with blowers and so forth, you got to have a multimeter on your truck, even if you don't know how to use it. Because when you call in for any kind of troubleshooting support to a manufacturer or somebody that's trying to mentor you a little bit, first questions they're going to ask is, okay, check the voltage here, check the voltage there. Tell me the amperage draw that pump's doing. And many situations where if you don't have a meter, we're already dead in the water. Can't help you over the phone. And somebody's going to have to go out to the site and help you out. So even if you don't know how to use it, they'll be able to talk you through how to use that. So you should have that. Now pumps, you get involved in pumps, as we discussed yesterday also, is there's no standards on installation practices. And so you're going to run into all kinds of different situations, and oftentimes they're going to be dangerous situations that could put somebody in compromise with confined space and so forth, and hydrogen sulfide gas and so forth that could occur in that tank. So you want to make sure that the pumps and floats are easily removable and serviceable for installation. So water in the junction box, got to check junction boxes. Whether they're outside the panel or inside, you want to check that box, see if there's any corrosion going on those connection points. Or in this case, that junction box is flooded with water. And so we're going to have to deal with that situation. Then next thing, always expect the unexpected. You never know what you're going to see in a system. One of the installers here many years ago, he was just going crazy trying to troubleshoot this. Just kept getting a low-level alarm going off all the time. And so he changed floats, and then he thought he had to change the control panel, or maybe a bad pump. Something's going on. Couldn't figure it out. So he and I went out there and troubleshot it, and had a bunch of frogs come out of it. And it's wintertime. So how do these frogs survive in that tank? And what you can't really see in the picture there is right on the bottom of that pipe, on the top plate of it, above the balls on that little splitter mechanism. It's for a recirculating system. There's a little blob coming out of there, and it's a dead, decayed frog that was kind of choking it off. So everything was getting sent out to the field instead of going back into this recirculation tank. So never would have guessed in the world frogs in the tank. So another contractor last year sent me a picture. He had a snake go into a control panel, went behind the circuit board and shorted out the circuit board. How a snake got in there? No idea. So to conclude, there is a demand for service providers out there. We're severely lacking them out there. Again, it takes a little bit more time and effort to learn all the characteristics and so forth, but attend any training that you can just to build up your building blocks a little bit and get out there and just do it. The ones that are doing it right now, especially if state code goes through, the ones that are doing it right now, they're going to be one step ahead of their competition. So really encourage you to get involved and do that. Again, seek out somebody that can help mentor you, through the processes and so forth. So with that, I don't know how much time I have left. I don't know if anybody has any questions. So, any questions at all? Dave.
You brought up the grease a few reels ago. Explain to everybody what it takes for that grease to gel up, what temp.
To gel up the grease?
Yeah, what temperature does it really gel up?
Yeah, so grease comes in several forms. You get, solid grease like butters and fats and so forth. And above room temperature, that's going to start liquefying and go through that tank. And again, a lot of, everybody's kind of switched to vegetable oils and so forth. So you want that to kind of accumulate in that tank. So in that particular, obviously it's not going to solidify. But to answer your question, Dave, above room temperature, it's going to start flowing through. I do know that Dave is involved in a restaurant project where they're having tremendous amount of grease problems. And the temperature, they're just really scalding that water coming out. They got that cranked way up. And to deal with anything on that system, you actually got to wear gloves because that water is so hot. So as a result, on that particular site, grease is just, despite the fact, I don't know any other restaurant in the state of Michigan, that particular restaurant has 30,000 gallons of grease traps, not including your septic tanks, but grease traps. And everything's flowing through because it's so hot. And you go into the tanks that it's co-mingling with, they're hot. And so as a result of that, you're getting fat, oil, and greases through the system, compromising it. Secondly, you're killing off bacteria at that heat level. And secondly, pumps can't handle that heat either, and you're going to fail your pumps earlier. So a lot of compounding issues as a result of that. So, yes?
What's your opinion on additives?
On additives? You know, every time you go to the bathroom and flush your toilet, that's the additives that are needed in the tank. Now, I've seen some benefit, so there's been a lot of studies on additives. Most of them have been inconclusive. Some of them actually have verified that it actually does some more harm. Most of them, there really wasn't any evidence that it did much. However, I've seen evidence in situations where we got a troubled site. And if you put some additives in that particular type of a setting, you might be able to bring things back and so forth. So, and I've seen positive impact with that. So, but just regular, telling a homeowner to, put this pouch in the tank once a month, there's no evidence to really support that. Yes. Yeah. So there are a couple of them that I know that studies actually showed that, the advertisements are true. You don't have to pump that tank out as much, but you're moving everything. You're bulking up the solids. You're moving everything downstream. So all right. Oh, yes.
I was just going to make a comment that you just got to watch your products. You're not killing stuff in your tank.
What's that? I'm sorry.
You're talking about additives.
Yes.
Well, in order not to kill your bacteria, you got to watch your products that you're using in your house. Cleaning products, least amount of bleach type stuff you got going down your drain. All that stuff.
Yeah, so the comment was, with the additives, you really got to watch what that owner is putting down the drain that could compromise systems. So if they're putting down things that are compromising it, perhaps additives may work in that particular situation, but exactly. For the most part, they're throwing money out. So really, you got to educate them on proper usage, look at the products that they're using, and so forth. That's the best bet.
Three things is toilet flushing, don't use the tiny bowl type products.
Yes. Yes.
Clothes washing, the least amount of chemical type stuff you put in better.
Yep.
And dishwashing, is a lot of dishwashers that bleach.
Exactly. Yep. So, all right. With that, I think we're ready for the next speaker. So.